Okay, let's take a look at number 23. Hot dogs and the corresponding caloric and sodium content. The caloric contents and the sodium contents in milligram of 10 beef hot dogs are given. Okay, so what I want to do is I want to get the correlation coefficient and the regression equation from the calculator. Okay, so previously I went ahead and put the information in the calculator. I went to Stat, Edit, and I have the calories as my X list and sodium content for the Y list, which is list 2. Okay, to get the regression equation and correlation coefficient, I want to press on Stat and right arrow over to Calc. And you'll see choice 4 is linear regression AX plus B. Okay, so I'm going to select 4, and then it will ask me where my X list is and my Y list is. So I leave that as defaulted. I want to go ahead and clear out this frequency list, make sure that's blank, and then calculate. Okay, so here's my corresponding regression equation. Here's the slope, okay, about 2.47, and a corresponding y-intercept of about 80.81. Okay, so I can go ahead and write that. Okay, so my estimated regression equation would be about 2.47x plus 80.81, okay, with rounding. Okay, oftentimes textbooks put the intercept first. Okay, so either one of these answers is acceptable. Okay, so looking at our output, I have a correlation coefficient of about 0.906. Okay. Now, if your calculator did not give you R directly, what you need to do, and you only need to do this one time, is you want to go to Catalog, which is right above your 0 key. So I'm going to press second 0, and you'll see a list of all the functions available on the calculator. I want to scroll down to Diagnostic. I might have to scroll down a while. Okay, Diagnostic on. Okay, so you want to turn that on and then press enter again. Okay, after you do that step, when you go back to your linear regression AX plus B, your output will include R and R squared, which is the coefficient of determination. But for what we're concerned with is we're concerned with whether or not the relationship is linear. So we can do that by comparing R of 0.906 to a critical value in table 11. Okay, so this is a very simple hypothesis test here. We're testing whether or not there is no linear relationship between X and Y. Okay, this is supposed to be rho, the Greek letter rho. Okay, so this corresponds to no linear relationship versus rho not equal to 0. Okay, that would be a linear relationship. This is also the same thing as testing whether or not our slope is equal to 0, okay, for the corresponding regression equation. Okay, so what we want to do is we want to compare R to a critical value in table 11. Okay, so to use table 11, we're going to need the number of pairs. So n would be equal to 10 pairs of data. And going to table 11, it's in the back of your book, I want to read down first to the number of pairs and then over to the critical value. I've got two options here, a significance level of 0.05 or a significance level of 0.01. So if we're going to go ahead and use 0.05, 0.632 would be our critical value. Okay. So we want to compare the absolute value of R to a critical value from table 11. Okay, so if R, in terms of absolute value, is greater than the critical value from table 11, then we can say we have a linear relationship. Okay, so our R value was 0.906. Okay, that indicates a positive linear relationship. If R was negative, I would be taking the absolute value of that, and that would yield a positive number. Okay, so my critical value was 0.632. So my question is the absolute value of 0.906 greater than 0.632? So yes. Okay, so we're going to reject the null of no linear relationship. So we're in favor of the alternative, which is a linear relationship. Now, the sign of R will tell me if that's positive or negative, and the corresponding scatter plot should indicate if it's a positive linear relationship or negative linear relationship as well. So since R was deemed to be significant, we can conclude there is a linear relationship between, I forgot what this is about, caloric content in the hot dog and sodium content. Okay, and going back to the problem, once we determine that R is significant, we can go ahead and use that regression equation, okay, to input some x values. So going back to the problem, since R was determined to be significant, we can use the regression equation. If R was not significant, we wouldn't bother finding the regression equation. And the best predicted value for Y would be Y bar, okay, the sample mean for sodium. Okay, so to answer part A, I won't do all of them, but let's take a look at part A. Okay, so we want to predict the sodium content for a hot dog that has 170 calories. Okay, so let's go ahead and input that into the regression equation. Okay, so for 170 calories, okay, the predicted value of Y would be 2.47 times 170 plus 80.81. Now if I had carried this out further, I might get a slightly more accurate value. You just want to make sure you round as directed in the homework. Okay. So 2.47 times 170 plus 80.81. Okay, that's about 500.71 milligrams of sodium. Okay, if we look at our table, we have two actual values corresponding to 170. Okay, so one observation was 470 milligrams and another observation was 530. The predicted value using the regression equation was 500.71.